Hello, everyone. My name is Emmanuel Anoma, and I'll be taking you through the course Fluid Mechanics. Here are some areas we'll be tackling through the course. The first area is characteristics of what? Fluid. The second being fluid statics, and lastly, dimensional analysis. If I may ask, what is fluid mechanics at all? Fluid mechanics is a science that deals with behavior of fluids, whether at rest or in motion. Fluid at rest are assumed zero velocity, and fluid in motion, the velocity is undefined. That means we have different velocities for that. Fluid in static or fluid at rest are called static fluids, and fluid in motion is fluid dynamics. But in this course, I'll be taking you through fluid statics. That means we are assuming the velocity to be zero throughout. What is a fluid, if I may ask? What is a fluid? A fluid is any substance that deforms continuously whenever a shear force of any magnitude is being applied on it. Now, let's move on to the areas where the application of fluid mechanics is relevant. One application is in the aerospace field. That's the aerodynamics, where we deal with fluid, and the specific fluid being used there is gas or the air. You find the drag and lifts and all those. Also, we go to hydrodynamics, where the fluid medium is water. We also have the gas dynamics, where fluid with different densities are being computed for. Now, let's move on to the applications of fluid. We apply fluid throughout our daily lives, in our homes, at our workplace, even in our bodies, fluids work. We can talk about the HVAC system, the air conditioning and refrigeration. Our human body, the blood vessels, they deal with fluids. You can also talk about vacuum cleaners. They are all applications of fluid. Now, talking about the properties of fluid, we have a lot of properties of fluids. You can mention them. We have we have density, we have viscosity, we have surface tension, and many more. Now, classifying the fluids, we have two types of fluids. We have the liquid, or what others may call water, and we have the gas or air. These two have similarities, and they also have differences. Let's go straight and find their differences. What is the difference between fluid, that's water, and also the fluid that comprises of only gas? So if we take the fluid that is a liquid, and gas, we can talk about its compressibility. You can bear with me and try this in your homes, that it's practically impossible to compress a liquid. You can't compress water. But for gas, gas can be compressed. So that's one differences between them. So liquids can't be compressed. But gas can be compressed. We can also look at one difference, that the liquid takes the form of the container. Whenever you pour water in your water bottle, it takes the shape of the container. So it means, in terms of shape, the liquid takes the shape of the container. But for the gas occupies the volume of space. So those are two differences. We can also give many more. That's for the gas, it does not have any fixed volume. But for the liquid, it has a fixed volume, which is the volume of the container. For the gas, it has no free surface. But for the liquid, it has free surface. And when we talk about free surface, it only occurs when it only occurs in the fluid when the fluid is not fully filled. It means the top of the surface of that fluid, that makes it the free surface. But for the gas, you cannot determine it because it moves freely. The particles or the molecules inside are widely spread, so you can't get that. This is the overview of what we'll be discussing. In our next video, we'll be talking about the classifications of fluid, how fluids are classified in our next video. Thank you very much for watching this video. Like, subscribe, and turn on your notification bell.